We are honored to have you with us, Dr. G. Suresh Babu, a seasoned academician and researcher with over 3 decades of experience in teaching and mentoring. He is currently serving as a professor in the Department of EEE at CBIT Hyderabad, where he has been inspiring minds for over 26 years. Dr. Suresh Babu holds an ME in Industrial Drives and Control from Osmania University and a PhD from JNTU Hyderabad. He has guided 30 plus ME projects and 3 PhD scholars and is a recipient of prestigious awards, including the Dr. APJ Abdul Kalam Best Teacher Award. His interests are diverse, ranging from electrical drives, renewable energy, energy management, to the profound wisdom of Vedic mathematics and Indian knowledge systems. He also serves as a master trainer under the UGC AICTE IKS initiative, promoting our Bharatiya Janana Parampara. Welcome, sir. We are honored to have you with us today, sir.
Thank you very much, Aishwarya. Shall I start sharing, please?
Yes, sir.
Okay. Is it visible, please?
It's loading, sir.
Aishwarya, is my
Sir,
slide visible?
yeah, it's visible now. It's
Shall I
visible.
start?
Yeah, sure, sir.
Okay. Thank you very much, Aishwarya, for your nice words. My dear participants, Sri Guru Bhyo Namaha. The topic given to me is condition monitoring and fault diagnosis. Okay. 1 minute. Next. Not moving. ML in electrical engineering. The repertoire of somehow full function 5 is not working now. Yes. Is it okay now?
Yes, sir.
The repertoire of my lecture goes like this. I request Aishwarya to frequently respond to me, please, because whether it is visible or audible or not, I request Aishwarya on behalf of organizers to respond frequently, please. Aishwarya. Okay. Repertoire of my sequence goes like this. Invocation, session objectives, expected outcomes, exposition, key takeaways, introspection, peroration, and acknowledgement. It is my tradition to start any such deed by saluting my parents. So now also, Mataram Subbalakshmi Tam Prema Rupam Namamyaham Pitaram Ramachandran Cha Kotlur Yanvayasanmani. Session objectives. Why this session? Actually, as Aishwarya said, the total session is trifurcated. So myself, Narahar Shastri, and Anubhav Kumar, we are sharing the dais. So myself being the first one, I am talking about the basics of that one. So session objectives of my slot are like this: to introduce participants to the fundamental concepts and importance of condition monitoring in electrical machines and systems. So that is, let them understand why vigilance is the first dharma of maintenance. My dear participants, remember, vigilance is our dharma. So the first dharma, covered dharma rakshati rakshitaha. If you really vigilant about the vigilance, automatically it will protect the total system. That is the meaning. The second objective of this session is to provide an overview of fault diagnosis techniques and their integration with AI ML algorithms for predictive maintenance and enhanced reliability. The word fault diagnosis is like a misnomer. Diagnosis is not fault. We are diagnosing to identify the fault. So be careful about the word. Fault diagnosis is no. Diagnosis is not fault. We are diagnosing to identify the fault. Okay. Next. What does it mean? Second objective means may they appreciate, that is participants, how intelligence transforms maintenance from reactive to proactive. That is second objective of the session. Next, coming to expected outcomes. Phalaswarupaha. First expectation is participants will be able to define and differentiate between condition monitoring and fault diagnosis with suitable daily life examples and technical examples too. That is first expected outcome. Second one is participants will gain superficial yet practical awareness of how artificial intelligence and machine learning techniques are applied in fault detection and predictive maintenance within power systems. I'm not going to talk much about predictive maintenance as my predecessor will take care of that one. Just I give only power systems also. Anubhav Kumar will discuss more. Just I give very basics of that one. Coming to prologue. So what is condition monitoring means? Keeping an eye in all the systems. So this is best understood. Condition monitoring. You have to go on monitor without disturbing the system operation. How vigilant we are on the machine. So condition monitoring and fault diagnosis, the vigilant eye of electrical engineering. There is one saying in Sanskrit, Yada sutram vichidyate tada vyatha jata bhavati. Whenever the thread breaks, suffering starts, arises. Yes, you should always anticipate in advance and save, protect the equipment and system too. What is condition monitoring? A proactive technique to assess health and performance of equipment during normal operation without interrupting it. It detects incipient faults before they escalate to breakdowns. That is condition monitoring. Why it is critical today? So it is so buzzword, it has become an industrial scenario. Why? Because it downtime costs are enormous, both economically and in terms of grid reliability and human safety. Condition monitoring is integral to predictive maintenance, enabling planned shutdowns and optimized maintenance schedules. Still, if it's not clear, let us see what exactly CM means. CM means the continuous observation of equipment health, continuous observation of equipment health to detect any change indicative of developing fault without interrupting operations. That is the best definition of condition monitoring. So what are the types of condition monitoring techniques are available? One by one we'll see it. Technique, what is the parameter monitored? An example application we'll see. First one, vibration analysis. The parameter being monitored there is bearing defects, imbalance of the wheel, etc. Example, in motors and generators, we apply this vibration analysis. Second one, thermography. In thermography, hot spots, overheating is identified, monitored. Example is transformers, switchgear equipment, etc. Even alternators also, machines also, you will find using a remote thermometer and will be able to identify hot spots. Next, third one, oil analysis. It will be used to monitor contaminants and wear particles in oil. The best example point is transformer and gearboxes. Next, continuation to this one, ultrasound technique, that is to find out leak detection, arcing, etc. It is found in compressed air systems, insulation faults. Next one, partial discharge measurement. That is insulation degradation in case of transformers and other HV equipment. Last but not least, electrical signature analysis. Electrical signature analysis. That is things that technique is being used, and it is found in induction motors. It is found in induction motors. Am I audible to you, please, Aishwarya?
Yes, sir, you're audible.
Thank you very much. Now, assessment of how frequently even a healthy person after crossing 40 years of age goes for regular checkup once in 6 months or once in a year without interrupting any day-to-day activities. That's called condition monitoring. In our health master health checkup, so many offerings has come from different organizations. We know it. So that is called condition monitoring. Okay. What exactly, why what is condition monitoring is important? If you don't monitor, what will happen? It prevents unbalanced downtime. First one is it prevents unplanned downtime. All of a sudden, a person collapses. If particularly he has not taken care of his BP, sugar, and other cardiac maintenance, all of a sudden he may collapse. Similarly, the machine also, if it is not properly monitored the condition, one day, several days will occur to the machine. So the condition monitoring will prevent unplanned downtime, first one. Second one, it reduces maintenance costs because there is no need. Once you are aware that what is your BP level, sugar level, and other organs are at what level, you need not to spend much on medicines for maintenance costs. Similarly, for machines also, if you are able to monitor the condition of the equipment or machinery in advance, maintenance cost will be reduced. That is second advantage. Third one is it enhances safety, yes, and reliability. So once a person goes regular health checkups and is intact with health, he is safe and reliable, no doubt. Same thing applicable to machines also. Next, so this is called equipment failure cost pyramid. Repair cost reduces, replacement part reduces, equipment damage reduces, loss reduction reduces production. So all these things together, which will lead you to safe and reliable operation of equipment for a longevity. That is about failure cost pyramid gives us. Next, second one, vibration analysis. It's another technique of condition monitoring. Vibration analysis. What is vibration analysis? It measures mechanical vibrations to detect anomalies. To detect anomalies. For example, daily life example, if you take car steering vibration. If it is not proper, we will go. If you take to the workshop, the technician says that wheel must be balanced properly, sir. So please leave your car here for wheel balancing. So like that, that is daily life example for vibration analysis. Technical example, motor being analysis using accelerometers. They will test with the accelerometers. That is vibration analysis. If you see the graph, FFT, fast Fourier transform technique, spectrum showing bearing fault frequencies for different frequencies, different amplitude you will be able to find at different times. This is only an example, it's not a case study. Next, second condition monitoring technique is thermography. What is thermography? It detects hot spots via infrared imaging. I told you, camera will be there, infrared remote thermometer, or we call pyrometer in industry to measure high temperatures. So it will be able to measure infrared imaging hotspots where it is. What is hotspot means? Where more heat is focused compared to the uniform distribution of heat. Daily life example, if you want to give fever gun temperature scanning. So nowadays, if you go to a doctor, the days has gone, touching and keeping with the thermometer inside the mouth and all. Just with the fever gun, you'll be able to know what the temperature is there, how much, because it is probably this area, it will be more hot spots you find rather than the body. Though that's why they'll be able to keep the fever gun here and identify what is the temperature. Based on that, they will diagnose. Technically, switchgear thermography revealing loose connection hotspots somewhere. So this is image you can understand 20 degrees centigrade to 80 degrees centigrade. So you find here in this 72.3 degrees centigrade is hotspot for the machine identified by the system or the instrument. That is called hotspot, which is checks oil for degradation, contaminations. Sometimes oil will be contaminated due to some humidity or etc. etc. So that we have to frequently check. So daily life example for this oil analysis is checking dark engine oil for replacement. And technical example is transformer oil DCA detecting acetylene for arcing faults. So this is the graph which you find concentration and thermal and electrical faults for different gases H2, CH4, C2H4, C2H2 type of faults. You'll be able to know where exactly thermal fault up to what level and electrical fault what level due to what concentration. This is only, once I told you, to give an idea about analysis, not any case study. Next, ultrasound analysis. What is ultrasound analysis means? It uses high frequency sound for leak or be able to hear human being for leak or discharge detection. Daily life example is hissing sound in detecting gas leak. Practically in our domestic, if you find gas pipe running right from outside to inside kitchen. So if you find any leakage, find some hissing noise. That is sound analysis. But here in industry, ultrasound analysis means compressed air leak detection using ultrasonic detectors will be done. This is also another type of condition monitoring. You can see the example how it looks like. He is monitoring, just keeping that sensor on the surface and tracing its position through the display. That is called how this is ultrasound analysis being done as one of the condition monitoring technique. Next, partial discharge measurement. What is partial discharge measurement? It detects micro electrical discharges indicating insulation degradation. So, simple example: if we are weak, our enemy will try to get. So we should see that we should not become weak. That's the best. So insulation should not degrade. If insulation degrades, electrical discharge starts. Daily life example, spark from old socket, which indicates insulation failure. Technical example, high voltage cable partial discharge testing for insulation life assessment. Especially in transformer oil, we do this partial discharge test. See, this is a partial discharge detection waveform, amplitude versus time. It's not any case study, please. Next, electrical signature analysis. What is electrical signature analysis? Monitors current and voltage signals for abnormalities. This electrical signature analysis is very, very important. It monitors what is the voltage, what is the set voltage, set current. So if any abnormality occurs in the system, so those two values will vary. that will give indication that yes, there is very much badly need of electrical signal analysis should be undergone. Daily example is hearing distorted speaker sound indicates damage. So hearing without hearing impaired, how a dumb person will be able to know. Hearing distorted speaker sound indicates damage. That is daily life example for electrical signature analysis. Just only manual example. Coming technical example, MCSA for detecting rotor bar faults. Very, very important, especially eccentricity, rotor eccentricity, area of eccentricity is found out by electrical signature analysis. Rotor bar faults in induction motors. So this is the current spectrum of broken bar side bands. How from 200s to 400s amplitude and vary. 1 second, please. Next, fault diagnosis. The what is second part of my topic is CM and FD, condition monitoring and fault diagnosis. So I told you the name very interesting. Diagnosis is not fault. We are diagnosing to identify the fault. Fault diagnosis. Be careful about the word meaning. So what is the process being taken? For example, in daily life, doctors diagnostic flow or fever. So what is the questions he asks? From which parameters he will be able to diagnose that we are suffering from fever. So it is a regular process, everybody knows it. That's called diagnosis applied by the doctor to identify the fever which is found for human being. Technically, fault location. There are three stages to identify or to overcome them to carry out the fault diagnosis process. Detecting, isolating, identifying. Remember, these three stage formula is most important for any fault diagnosis. First, you should be able to know whether fault occurred or not. Yes, occurred. Where it has occurred? What is the fault? If these things, if you put inquiry, automatically you will be able to diagnose the fault perfectly. Then taking care, or to call in case of a regular diagnosis called medication. In our industrial, this fault diagnosis terminology, we call maintenance. Predictive maintenance can go for it. Predictive maintenance or immediate maintenance. That is it follows the process. Let's see. So fault diagnosis process takes place in three stages. I said detection. Is there any fault? First. Next, isolation. Where is it? Immediately you isolate from the healthy circuit. Identification. What is the fault? Whether it's a line to line fault, a line to ground fault, or a insulation to insulation fault, short circuit fault, open circuit fault. So identify automatically, accordingly, the compensation, rather maintenance will be done accordingly. Once the properly diagnosed, medication is very easy. All of you know it. In medical terminology for human health also, diagnosis plays a vital role by doctor. Once properly diagnosed, and medication is very simple, very simple. So next, let's see how the flow chart looks like. 1 minute, please. 1 minute. Sorry. Path for fault analysis. Fault detected, yes or no? Yes. Detection. Has the system sensed in an abnormal condition? Yes. Then isolation. That is where the fault localized to component circuit alone. Next, identification. What exactly is the fault type? I told you, know, there are number of types: open circuit fault, short circuit fault, line to line fault, line to ground fault, single line to ground fault, double line to ground fault. All these faults, once the properly identified take corrective action. That's how next corrective action only. So artificial intelligence and machine learning in condition monitoring and fault diagnosis. What is it? It automates detection and classification using data-driven models. First point. In daily life, how can you correlate? Smartwatch, ECG detecting all other cardiac or sometimes pulse rate, everything it is nowadays smartwatch, all of you know. That is best example in AML, artificial intelligence in a health condition in our day-to-day life. Coming technical life, CNN, convolution neural network models are there. They classify the motor very fast with more than 95% accuracy. CNN, that is convolution neural network models. Next. So it is carried out in 3 stages: data acquisition, feature extraction, and model prediction. Data acquisition, feature extraction, and model prediction. That is carried out in 3 phases. Next. AML technical example. Suppose if you take case predictive maintenance for motors. Predictive maintenance for motors. Vibration plus temperature data fed to ANN, neural networks, which predicts RUL, that is remaining useful life. Remaining useful life. That is residual life assessment. Separate software is available. It is designed by BHEL R&D. RLA, that is residual life assessment of any machine. So it predicts impact on this one. Impact on this one is maintenance planned before catastrophe failure occurs. That is called predictive maintenance. Prevention is better than cure. We know it. So that is AML technical example. Same can, if you see graphically represented, remaining useful life versus time. So actual remaining useful life and predicted life. How, and if you can closely observe, this is remaining useful life. As the time progresses, how it is falling down, and if it is not properly taken, failure occurs at one point of time. Of time exceeds, it failure will occur, breakdown will occur in the machine. Next, what are the emerging trends in this area? Majorly, I will tell 3 emerging trends. That is one digital twin, we call digital twin. The daily analysis of this digital twin is Google Maps live traffic, which we notice in Google Maps. Technical example is virtual substation replica. Virtual substation replica is best example for digital twin. And Edge AI trend. There is voice command processor in phone, which we find. In coming to technically, condition monitoring, IoT, Internet of Things sensor level is called technical example. And last but not least, sensor fusion, that is sensing danger via multiple sensors. Even multiple sensors connected for a system, you'll be able to know by taking the inputs from all the sensors, you'll be able to know what type of fault going to occur. So it's nothing but multiple sensors. In technically combining vibration analysis, thermal analysis, acoustic analysis, all together identifying at for a single system is another trend setting nowadays. Sensor fusion we call. This is smart grid with a digital twin, is this block diagram. Next, what are the research directions in this context? Hybrid machine learning models for multi-fault diagnosis. That is one of the best research direction. For multi-fault diagnosis, hybrid machine learning models are being arrived. Transfer learning for generalizing fault models. Transfer learning is another research domain. Acoustic emission based condition monitoring for high voltage equipment. Last but not least, blockchain integration for secure condition monitoring data management. So if you see research directions in a tree form, hybrid ML models for multi-fault diagnosis, acoustic emission-based condition monitoring for high voltage equipment, there are branches. Transfer learning for generalizing fault models, and blockchain integration for secure condition monitoring data management. Like this, it is made in 4 different branches, the tree being condition monitoring. And these are the essential directions condition monitoring. So this is a small topic because I told you the very big topic is trifurcated under 3 different people has been given small topic. I have finished my thing. Let me give highlight, conclude. Let us key takeaways, whatever I have said so far. May we engineers uphold the dharma maintenance, ensuring every transformer, motor, and live wires have its full life in service of society. That is dharma. Next, a very interesting quotation. An engineer who masters condition monitoring, he guards the temple of reliability. An engineer who masters fault diagnosis becomes the priest who restores its sanctity when disturbed. So you see, the person who masters condition monitoring, he guards, safeguards the temple of reliability. The person who masters about fault diagnosing the fault identification, he becomes the priest who restores its sanctity when it is being disturbed. Next, imagine your heart skipping a beat. Loved up, loved up, loved up. Would you want to your smartwatch to alert you instantly? Yes. Similarly, your transformer, motor, or switchgear deserves that constant vigilant friend that is nothing but condition monitoring integrated with AI fault diagnosis. Okay, my dear participants, this is the highlights. Before finishing my talk, let us introspect ourselves how much we have understood. I hope I don't want to test you, but it is left to each individual how much we are able to answer these questions. Be vigilant. First question: which of the following techniques is commonly used for detecting bearing defects in induction motors? Anybody can answer. Which of the following techniques is commonly used for detecting bearing defects in induction motors? Thermography, vibration analysis, oil analysis, pocket measurement. Anybody to answer, please? Nothing will happen if you answer.
Vibration analysis.
Huh?
Vibration analysis.
Very good. Yes, it is vibration analysis. Next, second question. It's only to know how much we have understood, that's all. We are not going to grade anything at all. Predictive maintenance aims to repair equipment only after failure, replace components periodically, or predict failures and perform maintenance just before they occur, or eliminate maintenance completely. Which one is correct answer?
C.
C. Very good. Excellent. Navamita Banerjee. Very good. Third question. Which AI model is best suited for time series forecasting in predictive maintenance? Which AI model is best suited for time series forecasting in predictive maintenance? CNN is convolution neural networks. LSTM is long short term memory. Third one, decision tree. Fourth one is K-means. Which one? Time series.
LSTM. LSTM.
Exactly. Exactly. Very good. LSTM. Because time series. Next, partial discharge measurement is primarily used for monitoring. Partial discharge measurement is primarily used for discharge monitoring. A. Mechanical misalignment. B. Electrical insulation degradation. C. Temperature rise. D. Oil contamination. Answer. Partial discharge.
B. B.
Very good. Banerjee, very good. Very good. Next. Fifth one. In AI-based fault detection of power systems, convolution neural networks, that is CNN, are used because They detect time dependencies in sequential data. They classify high dimensional spatial patterns effectively. They perform clustering of non-labeled data. They optimize PID controller parameters directly. Which one is correct answer? Anybody to answer? Banerjee?
Someone has already given the answer as B. I think,
Very good.
yeah, in the chat box.
I have not seen chat box. Okay, thank you. Thank you very much, Banerjee, for your cooperation. Okay, conclusion and the call to action. May these objectives, whatever I said, outcomes expected and questions become tools to chisel clarity in the minds of learners. Knowledge without testing is like gold without fire, unproven and unrefined. So it must be tested. Knowledge is there means whether it's a natural knowledge or artificial knowledge, it must be tested. Then only it will be proven. Otherwise, gold without fire. And I hope I reach you with fulfilling the objective set at the beginning. And I acknowledge all these people, to all my teachers, students, to my motherland, to my mother tongue, to the authors of all the books I read, CBET authorities, and you who has patiently listened to me.